Hola, hola. Bueno, muy buenos días para todos.
Hello, good morning, everyone. My name is Javier Infamoso. I work in the development team of GeneXus and particularly in generators for Apple platforms. I'm going to ask you a question. Do you know what's in common in these three devices? Each one of them starts a new change in user interactions. The first one is the first Macintosh of 1964, and we didn't know what that device was, and it's a mouse. Then we went to interface of command lines. We used the keyboard, pointers, and interfaces. I was very popular, Windows and the IRPC. Then the one in the middle is the iPhone that we all know, the original one. It was released in 2007. It started a revolution of modern computing, screen touch, interaction based on our fingers and gestures. And the third one is the one I'd like to talk about, is the Apple Vision Pro. It was announced this year. And it wants to start the spatial space communication and interactions. Everything around us will be cameras for our content. It also introduces important changes in their interactions. We have to get adapted to these changes, and we, as developers, is something very important. If you do it with GeneXus, things are much easier. Why am I saying this? Because the previous versions were already known by GeneXus. They are past. So my idea is that you go into this new platform and you have to know that GeneXus is ready for it. So in the first thing, I'm going to be talking about this new device, what its features are. Then we're going to talk about platform and what the fundamentals are. And lastly, we're going to be talking about the application development. So let's start. What is this new thing, this new device? The Apple Vision Pro is a new type of computer, which is based on the augmented reality, where everything around is an available camera for a digital content. We use it as glasses that we wear. It has a crystal screen at the front and very many sensors like cameras, infrared sensors, and so on. Some point focus forward, to the right, left, and down. The lateral bands focus on our ears, and then on the other side, in the interior, there are a couple of screens with very high resolution. Now, these screens aren't transparent. They reproject what the cameras at the front show, and they give us a vision of what we can see through them. Around our eyes, there are a group of sensors, the infrared emissions and infrared cameras, and the idea is to capture where our eyes are and what we are watching. Then there's a digital crown that we have in the Apple Watch and a button on the left. Now, this device works with a battery that is not in the device, but it's external so that it's not weighing on our head. And it can be plugged into the electric power. Now, if we look at the front, behind the crystal screen, there is a screen which shows a representation of our eyes in real time. Now, it does this so that when we are using it and interacting with a person, that person can know whether we are paying attention to that person or whether we are looking at something else. Now, in terms of authentication, in the same way you had Face ID in iPhone or Touch ID to recognize our fingerprint, there are internal sensors to recognize the iris in our eyes and trust that it's us, you wearing that device. This device was introduced by Apple in the conference of WWC of Apple in mid-year, and it's going to be launched in the market in early 2024, first in the US, and then in the future it will get to the rest of the world. This is a brief introduction about the device, but let's go to the fundamentals. VisionOS is the name of this new operating system for this device. It's a mixture of iOS, Apple iOS, and Mac iOS. This new device, it's a new platform, unlike touch devices. We're not watching at a screen. It's a completely different experience in that we look at all the content around us, and they are all around our physical space. All the apps are around. A great change in this platform is the way we interact with this digital content. We use our eyes, our hands, and our voice. Just an example, if I want to touch a button here, the only thing I have to do is to look at the button and do this with my hands. It's equivalent to a touch. But this platform also supports other gestures that we are used to do. For instance, to scroll, I would simply do like this with my hand. If I want to zoom, I would do it like this. If I want to rotate, the same. I'll do it with my hands and with all the other things in the system. And when we combine this type of gestures with the position of where our eyes are looking at, we have the possibility of having magical experiences. This is the native VisionOS photographs. I look at a place and I zoom in, and that's exactly the place that I'm looking at. If I look somewhere else, I would zoom into the place I'm looking at. These are the gestures of the system. This is indirect manipulation of the content. I interact on what I'm looking at. But this platform also supports direct manipulation, touching the content. For instance, let's suppose that I have a window that's closed and I can touch it and make a scroll. This is a virtual keyboard. Or if I had a 3D content, I can move it and touch it. These are the ways of interacting with this device. Another possibility is using our voice. If I want to make a search, I look at the microphone and start talking. The platform knows that I'm trying to make a search. Apart from this type of interaction, it also supports physical hardware. For instance, it's a keyboard or games or whatever. This is a very brief introduction of this platform. Let us look at how I can present digital content in this platform. It can be summed up in three types: windows, volumes, and spaces. The first two, the windows and volumes, are very similar. Both of them are used in a space called shared space, which is shared because several applications may be shown at the same time. I can look around what I see around, and then I can see these interfaces. The first one, Windows. This type of interface is thought out when my content is in 2 dimensions, text, images, and so on. But in some cases, in Windows, I can put in 3D content. It could open up one or more windows at the same time, and users at any time may drag the window, take it anywhere. It can be expanded or close it at any time. Volumes are very similar to Windows, but instead for 2D content, it's when you have 3D content. And so users can see it from different angles. And if you looked at Windows, you can move them and close them. But unlike Windows, they cannot be redimensioned, but it's the developer that gives the size at the time of making it. Then we have the third form of presenting content is immersive spaces. This type of spaces give you the richest possibilities, and apart from having windows and volumes in this type of apps, I can present 3D models anywhere in the user's space. A restriction of this type of interface of spaces is that one single application, only one single application can be in this space. In turn, immersive spaces can be divided into 3 modes. The first one is mixed, where what we called increased augmented reality. I can see all the space around me, and that's where I put my digital content. The extreme is the full mode. This is what we all know, like the helmets of virtual reality. I can't see anything around, just what I have there. And then we have an intermediate mode, which is progressive. I have half of my visual field, and with a digital crown in the device, I can become more or less immersive, depending on what I want, and you can move on to the complete mode or go to the mixed one. This most in immersive spaces, I can have access to more features of my device. For instance, in the immersive modes, I can follow up the movement of the hands of the user, or I can recognize the environment where the user is. Where is the ceiling? Where are the walls? Where are the tables? And I can make interactions using the knowledge of those things. Something I'd also like to refer to about this platform is the visual aspect of the platform. This platform uses a very familiar aspect to Apple platforms in order to introduce it more easily. For instance, here I'm using the Musca app. If we look at the iPad, music is very similar. However, there are some differences. For instance, in this platform, there is no clear mode or dark mode, light or dark. There is only one appearance to which my app must be adapted and works well in all modes. To do this, this platform uses an opaque crystal in different layers with different contrasts to be able to use it in all cases. This platform is not limited by a screen. Since it doesn't have any borders, we can put content even outside the window. For instance, here we have the music application, and we have a bar with controls, and on the left-hand side, you have the tabs in the platform. And something that it's particular when we look at it for some time, it would give you more information. They are called ornaments in the platform. The next thing I'd like to mention has to do with the scale or density of the platform. Basically, there are 2 types, the dynamic and the fixed one. What's the dynamic scale? Basically, as the content goes far away from the user, the scale augments, increases, so that I can see the object in the same size, even if it's further away. The purpose of this is that if I have something very far away, a text that's far away, I can read it easily. That's the default mode, and that's where you use most of its content. But there's also a fixed mode. The scale is fixed. When the object is further away, then you see it small. And you would use it for peculiar cases. For instance, suppose you want to show a model or a representation of a physical object of reality in this platform. If you really want to keep the real scale, you would use the fixed mode. And then when we talk about the scale, something that I haven't mentioned about the device is that it uses a renderized mode using a much bigger scale than focusing on the content than in the periphery, where the scale is smaller, just for performance purposes. 8x is the maximum scale densities, perhaps if you know the different densities, it gets to 8. The recommendation is to use assets of vectorial format so that you can see them well. The last part I want to mention as fundamental is privacy. The Apple platforms
consider that privacy is a very important factor, and this is no exception. As I was telling you today, I mentioned the hands, how they are positioned, so the environment, the objects in the physical space of the user. All those cases require asking for permission. If we don't get permission, the applications must work accordingly. Another thing I did not mention, all data captured by the sensors, we as developers have no access to those data. The operative system is the one that collects all the data, but we have no access to what the cameras show, for example. Finally, all of this works on the device, so this is private. Another privacy example I want to share with you. When interactive elements give you feedback to help you understand that they are interactive, so as not to affect privacy and to know what the user is watching, we highlight the aspect, but we never know when the user is watching that until he clicks finish. This is an introduction to the fundamentals of the platform. Now let's talk about the development of the applications. How are they developed? We use tools that we know, Xcode, Swift as programming language, and for the interfaces in 2 dimensions, we use UIKit as a framework. In the GeneXus world, this means that we are going to use the same ways to design content that we are used to. To design content for this platform in 2D will be the same. In terms of the visual aspect, GeneXus will use the DSN6, and GeneXus will automatically use the best practices for this, like opaque, crystal, and the ornaments that I mentioned before. Now, what about the 3D content? The 3D content is modeled using the USDZ model. We have a support, we have an external object, we can augment the rule. For basic cases in 3D interactions, like showing 3D content in other windows or volumes, we will integrate them very easily. One example. You have an e-commerce application. Instead of showing images, it can show a 3D model of the object we want to buy, and you can manipulate the object. And what about immersive spaces, the advanced cases? The short answer is that we are still researching how to produce this type of interaction. I will tell you how this is done in a native manner. We use a programming model that is a little bit different. It's based on a composition of elements. I'm not going into details about the programming, but Apple provides a tool for this type of content so that you can package them. And the first implementation for GeneXus applications to support this is to use that packaging of the tool and include it in the project. I repeat, we are investigating how to model this. Now, to test our applications, we do what we do with the other Apple platforms. We have a simulator. We use a mouse to simulate where we are looking at, and when we click with the mouse, it's a tap of our fingers, an equivalent. It gives us a possibility to change the position where we are, to change the environment where we are, and to be in the clear or dark model in order to ensure that our application adapts to all the luminosity styles and is clear to see. What about the existing applications? All applications we already have published for iOS. When this platform is launched, this year will be available in the App Store of VisionOS. Now, the applications will be compatible, which means that they will keep one aspect that is relevant for the platform for which they were designed. If my application is for iPhone or iPad, preference will be given to iPad. And if it's dark and light, it will be the option will be light. This is the iPad version running. And finally, and as a conclusion, what's next in terms of this platform? This platform is in beta modality with export. If you want to test your own applications, as I showed the GPN, you can do that with the current version of GeneXus. You have to use the beta to test it. And the next step is to support native applications with this device. The development of the support of this platform has advanced in the Apple generators. We don't have it available in any GeneXus version, but we'll have them ready in the near future in the GeneXus betas. Once the GeneXus version is available, I recommend first, try it, test this new application, and review to see if all the application makes sense. Most APIs are available in this platform, but not in all cases. So that's why I'm telling you, review your applications. The location APIs may tell you where you're standing, but the tracking of localization or proximity to certain things is not available. Another recommendation is to please favor vector-based assets. This platform uses layered application icons, and we have support for this type of icons, platforms that use the same type of format, so you can design your GeneXus icons in this platform as well. Regarding the layout, please favor a wider content rather than a taller content, because it's easier to move your neck horizontally and not vertically. So please maintain the most important content in the center of the layout and not in the periphery. And the last recommendation, thinking of the future, start thinking about a key moment in your application to develop an immersive space within it. This is a very, very brief introduction to the platform. We saw its characteristics of the new device, the basic fundamentals of its operation system, and also how applications are developed. And if we go back to the beginning of my presentation, apart from VisionOS, which is the beginning of spatial computing, I would like to mention the revolution we are going through with artificial intelligence. A short time ago, this device, AI Pin, was announced. No screen, it has a camera and a microphone, and we talk to it, and this goes to the LLM's artificial intelligence and response. What is my point here? We are facing enormous changes in user interaction. We, as developers, will need to adapt to that. And as usual, GeneXus will be there as it has been before. Thank you.